Essay 3.5 Unit Circle Part 2. So looking back at the unit circle and triangle inside of it, we can also use the trigonometry rule to define the tangent theta as b over a, but since a is equals to cosine theta and b equals sine theta. So let's start with the unit circle. So I'm going to draw a unit circle here. So let's draw unit circle. Okay, so we have a unit circle here, and I am going to draw a line inside of this unit circle and then name this point here as the point P. Okay, and we know that this is origin O, and from origin O to the point P we have length of 1 because this is unit circle. And if I draw another line here and identify this point as N, then I know that from origin to the point N is cosine theta, and from point P to point N is sine theta. So this is something that we have been discussed since last section. So also from this point, we also know that the point here is, let's name that this point as A, and then this point here is 1, 0, right? So this is something we know already. Okay, so let's try to identify the tangent with the unit circle. Okay, so let's first identify a tangent line. Okay, so I'm going to draw a tangent line here. Okay, so this is tangent line. So this is called the tangent line, and we call this a tangent line because the tangent line is referring to a straight line which just touches the curve at one point. Okay, so we call this green line here a tangent line because it touches the unit circle at this point here, point A. Okay, so since we have a tangent line, let's extend the line OP. So line OP, so let's use a different color. Okay, so we're going to extend this line OP to the tangent line. Okay, so let's extend it in this way. Then we can say that this extended line meets the tangent line at point Q. Okay, and when this intersection, so this intersection point, the position of the Q relative to A is defined as the tangent function. So this point, the position of Q relative to point A is defined as the tangent function. Okay, so the triangles, by doing this we get two triangles, right? The triangle O and P. So let's try identify this triangle. Okay, so let's try use green color. So we have first triangle which is O and P, right? So this is the first triangle, and then we have another triangle OAQ. So OAQ is happening this way. Okay, so they are equiangular and therefore they're very similar. Okay, so I'm going to write down that here too. So the triangle OMP is equal to triangle OAQ, and they are equiangular, so means they're very similar. And similar. Yeah, so we can say that consequently we can say that the line AQ over or line OA is same as line MP over line ON, and also we know that line AQ over 1, okay, so line AQ, this line here, over 1 is equal to the sine theta and cosine theta. Okay, so under the definition that we know that the line AQ is also equal to tangent theta, we can conclude that the tangent theta is equal to sine theta over cosine theta. Okay, and also since the point line OP has the gradient sine theta over cosine theta, so we have discussed this in the previous section, okay, but I'm just going to repeat this here. So line OP has gradient sine theta over cosine theta. We can also say that, we can also conclude that the tangent theta is the gradient of the line OP. And then let's talk about the ambiguous sine rule. Okay, so when using the law of the sines to find the unknown angle, we must watch out for the ambiguous cases. These ambiguous cases, so let's highlight some part here. So we need to watch out for the ambiguous cases. Okay, so this the ambiguous case happens when two different triangles could be created using the information, so informations or given informations by the question. So most likely when we know two side lengths and a non-included acute angle. Okay, things that I should mention before going into next part is discussing the difference between the things I need to discuss before going into the next part is the difference between acute and obtuse. So when you have acute, it means the angle is less than 90 degrees. When you have obtuse, the angle is greater than 90 degrees. Okay, so for example, let's look at this diagram here. Okay, so we have the triangle ABC. Okay, so we first know that we have a triangle ABC here. Okay, let's say that we were toward a angle here, the angle of the A, and I'm just going to give you a random number. So let's say we have a triangle ABC here. Okay, so we have a triangle ABC. Okay, and I'm just going to give a random numbers here. Okay, so let's say we have angle 33 degree. Okay, and we have a line AC, which is the 10 centimeter. And let's say we have line CB, which is 6 centimeter. Okay, you can see that if I draw another line right here, okay, then you can see that we have there are two different triangles that match the criteria that was discussed, right? And as you can see in this picture, either acute triangle or obtuse triangle could be created because of the side A, okay, side A, we have side A here, right? Side A could swing either in or out along the unknown side B. Okay, so this is side B. Okay, so let's say this is A prime. Okay, so you can see that we have an acute angle here, we have an acute angle here, and we got an obtuse here. We got obtuse angle. Okay, so let's talk about this again. Okay, so I'm going to just redraw the triangle. Okay, so let's say we have a triangle A, B, C, and we know that this triangle here is B, side B, and I'm going to just give you a random number just for understanding, more understanding. And then I can say that this side here is angle side A, and it has a 6 centimeter. Okay, and I can say that this is my 33-degree angle. If I just draw a line, let's say that I'm just going to create a line that has a 6 centimeter and it can swing in and out. Okay, then I can say that there can be a line can happen in this way, and I can say this line is my line point is meeting at the point M. Then you can say that we have obtuse angle, and we have a then we can say that we have an acute angle here and we have an obtuse angle here, right? Okay, then we know that this is a ambiguous case. Okay, and then we need to be on the lookout for the ambiguous case. Okay, so there are things that we can check to determine if there's a second valid angles. Okay, so let's write that in the next page. So to determine if there is a second valid case for the ambiguous, okay, we first have to see if we have a two side, if we are given two sides and the angle that is not in between those two sides. And this is the situation that we might have two possible answers. And then we need to find the value of the unknown angle. And also, third, once you find the value of your angle, you subtract it from 180 degree or pi, okay, to find the possible second angle. Okay. Then lastly, you add the new angle to the original side. The original side or original angle, okay? And if the sum is less than 180 degree, then you have two valid answers. If the sum is over 180 degree, okay, then second angle is not valid. Okay, so you have to remember that to have the ambiguous case of the sine rule, you always need to have the two sides and the angle that is not in between. Okay, and that is the situation where you might have two possible angles. Once you have checked the situation and you know that there might be a situation that where there might be have two possible angles, you first need to find the unknown angle, and once you find the value of your angle, you subtract it from 180 degree and find the possible second angle, and lastly add the new angle to this original angle and subtract it from the 180, and then if their sum is less than 180 degree, you have two valid answers. If the sum is over 180 degree, then second angle is not valid. Okay, so remember this last part. So once you add the new angle to this original angle, if the sum is less than 180 degree, then you have two valid answers. If the sum is over 180 degree, and then you have just one answer. So second angle is not valid. Okay, so let's do an example together. So here I have example. It says that if the line ACB equals 33 degree and side AC is equal to 10 centimeter and side AB is equal to 6 centimeter, we need to find the angle ABC if it is obtuse. So it seems like we need to find an angle that is an obtuse angle. Okay, so for this example, I first going to start with a diagram. So diagram, I just draw a triangle, right? And then I'm going to label it as A, B, and C. Okay, we know that the angle ACB is equal to 33 degree. Okay, and the side AC is 10 centimeter and side AB is a 6 centimeter. Okay, since we need to find the angle ABC, so this angle here, it seems like we need to use the sine rule, right? But however, before using the sine rule, the first thing that you always need to do is checking if this is a ambiguous sine rule case. Okay, so when you look at this diagram, you know that there are two sides, right? Two sides, and then we know the angle that is not in between. So we have an angle not in between. Okay, so in this case, we have an ambiguous sine rule case. Okay, means we will have two possible answers. Okay, most likely one being an acute and another one being obtuse angle. So we are trying to find this obtuse angle, right? I know my diagram is not in scale, but however, I'm just going to draw a line here, okay? And then say this is a 6 centimeter, and I have my second angle here, okay? So this is my B prime point, okay? So this is an acute angle. This is my obtuse angle, okay? So we're going to use a sine rule. So we know that the sine angle C over side C, and since we are trying to find angle B, I'm going to say sine angle B over side B, right? And then we know that the sine angle C or sine ACB is 33 degree. The angle ACB is 33 degree. So we can say sine 33 over the side C, which is the 6, and the side B, sine B over side B, which is 10. Okay. By doing this, I know that the angle B or angle ABC, my first angle for this case, is same as sine, inverse sine 0.9077. So it's about 65.2 degree, right? Then once you're at this point, since you got your first angle, we need to find our second angle, right? Just to find the second angle, using the description that we wrote here, we need to find the value, the second value, by subtracting the calculated value from 180 degree, right? So we have to subtract the first angle from 180 to find the possible second angle. So we can subtract 65.2 degree from 180. Then we get the value 114.8 degree. Okay, so you can see that we got the first angle 65.2, second angle 114.8 degree. Okay, so we got two values. We need to check according to the last point that we discussed. We need to add these two values together, see if the sum is less than 180 degree or over 180 degree. If the sum is less than 180 degree, then we have two possible answers, right? So we have 65.2. So we have 114.8 degree. These two add up to 180, right? So two answers are possible. So the answer is 114.8 degree, because your second value is an obtuse value.